So for today we're going to get the power series of this differential equation y double prime is equals to y. So we're going to let y is equal to the summation of c sub n x raised to n as n is equal to 0 approaching to infinity. So getting the y double prime is equivalent to the summation of n c n x raised to n minus 1, where n is equals to 1 as it approaches to infinity, and y double prime is equivalent also into the in the summation of n times n minus 1 multiplied by c sub n x raised to n minus 2 as n is equal to 2 approaches to infinity. So our equation would be equal to the y double prime minus y is equal to 0. So for us to solve it easily, so plug in the equivalent value of the following variables. So summation of n multiplied by n minus 1 cn x raised to n minus 2 minus the summation of c sub n x raised to n as n equals to 0 infinity. So 0. So for us to get the the x raised to n right here is equal right in this equation, so we're going to minus or subtract 2 here, in here, and in here we're going to add 2, and then add 2 also here, and then here also. So it would be equal to summation of n plus 2 n plus 1 c sub n plus 2 x raised to n. So now the same as right here. So n equal to 0 as it approaches to infinity. So bring this down. So summation n equal to 0, so infinity cn x raised to n equals 0. So the next thing we will do is to factor out the x raised to n. So x raised to n divided by the summation, or write the summation of n plus 2 n plus 1 c sub n plus 2 minus the summation of c sub n is equal to 0. So n equals to 0, n equal to 0, infinity, infinity. So our x raised to n is not equal to 0. So the following formula that will occur is n plus 2 multiplied by n plus 1. Sorry, I forgot to factor out this summation also. So this 1 is 0. Infinity is not equal to 0. So n plus 1 is c sub n plus 2 and cn equals to 0. So transpose the c sub n in the right side. So we're going to have the c sub n2 plus 2. C sub n plus 2 is equal to cn all over n plus 2 multiplied by n plus 1. Wondering, we divided it already, so we can get the simplest formula. So this one is your recursion formula, or recursion relation formula. So at n is equal to 0, c sub 2 is equal to the c sub 0 over 2 times 1. So c sub 0 over 2 factorial. So the next is at n equals to 1. So c sub 3 is equal to the c sub 1 over 3 times 2. So it's equal to the c sub 1 over 3 factorial. So right up there, I'm going to go up again. So at n is equal to 2, c sub 4 is equal to the c sub 2 over 4 times 3, where our c sub 2 is also equal to the c sub o all over the 4 times 3 times 2 times 1. So this one is c sub o over 4 factorial. So at n equals to 3, so c sub 5 is equals to c sub 3 over 5 times 4, where our c sub 3 is equal to c sub 1 over 5 times 4 times 3 times 2. So our c sub 3 is equal to c sub 1 over 3 times 2. So we could combine with them. So it's equal to the c sub 1 over 5 factorial. Sorry for my handwriting. So at n is equals to 4, c sub 6 is equal to c sub 4 all over 6 times 5, so it's equal to the, where our c sub 4 is also equal to the c sub o over 6 times 5 times 3 times 2 times 1. So here, so it's equal to c sub o over 6 factorial. So at n is equal to 5, c sub 7 is equal to c sub 5 all over 7 times 6. So the c5 is equal to the c sub 1 over 5 factorial. So c sub 1 all over 7 times 6 times 5 times 4 times 3 times 2 times 1. So it's equal to the c sub 1 over 7 factorial. So now we have our values of n. So we can plug this in the power series formula. So we can separate this through the even and odd coefficients. So the even coefficients, so y is equal to c sub o plus c sub o x squared all over 2 factorial plus the c sub o x to the 4th all over 4 factorial plus c sub o to the x raised to 6 times x raised to 6 all over 6 factorial plus that. So that is infinite, so that's why. So at odd coefficients, y is equal to the c1 x so c1x plus c1 over 3 factorial times x cubed plus c1 all over 5 factorial x raised to 5 plus c1 over 7 factorial x raised to 7 plus dot dot dot. So plugging in the power series formula could come up with y is equals to c sub y is equal to c sub o multiplied by 1 plus x squared over the 2 factorial, so 2 plus x to the 4th all over the 4 factorial, which is equal to 24 plus x raised to 6 all over 6 factorial, which is equal to the 720 plus dot 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 parenthesis plus the c sub 1 multiplied by x plus x cubed all over 3 factorial, which is equal to 6 plus x raised to 5 all over 5 factorial, which equals to 120 plus x raised to 7 all over the 7 factorial, which is equal to the 5040 plus dot dot dot. So this one, so the final answer would be c sub o times the cosine hx plus c1 sine hx. So this following power series has a equivalent transcendental function, which is equal to the cosine hx and the sine hx respectively.